quadratics. Okay, solving a quadratic equation then. So to solve a quadratic, it must equal 0. And if you look at the left-hand side on this equation, there is a common factor here of x. So we can take x out as a common factor, and that leaves us then with x plus 3. So x times x to get the x squared, and x plus 3 to get the 3x. It's always a good idea to do that. Check just to make sure you've factorised it correctly. Okay, so solving it now from its factorised form, well, either the x has to equal 0 or the x plus 3 in this bracket has to equal 0. That's the only way we can get 0 as an answer from this product. Okay, so either from that then x equals 0, or if x plus 3 is equal to 0, just a very basic equation, take the 3 away and we've got x equals minus 3. Okay, with the next example then, we have got 3 terms on the left hand side, but as you can see here, it is equal to 2 on the right hand side. So we have to have it equal to 0 to be able to solve it. So the first thing we're going to do then is take 2 away from either side, and that will leave us then with this new quadratic equation of x squared minus 5x plus 6 now is equal to 0. Okay, so factorising this quadratic on the left hand side, we're looking for 2 numbers that multiply to give positive 6, add together to give minus 5, and those 2 numbers then are going to be minus 3 and minus 2. So we've got x minus 3, x minus 2 equals 0. So again, these are being multiplied together, and to get an answer of 0, one of them or both of them must equal 0 itself. So if x minus 3 is equal to 0, x has to be 3. And for x minus 2 to equal 0, x has to be 2. Okay, with this example then you can see straight away we've got it equal to 5, so it's not equal to 0. And also here we've got more than 1x squared in the equation. So first things first, let's make it equal to 0. So just like before, we're going to take that 5 away. So taking 5 away from this slide gives us 2x squared minus 3x minus 5. And taking 5 away from here then obviously leaves us with that 0. So it's now in a form that we can solve. Okay, now to factorise this, you may be able to do it by inspection, getting your 2 brackets like so. Some of you may prefer to split the middle term. So we're looking for a number to multiply to give minus 10 and add to give minus 3. Okay, so those 2 numbers there are going to be minus 5 and positive 2. So if we choose to split the middle term, we've got 2x plus 2x minus 5x minus 5 equals 0. So using these 2 numbers, I have written them like so. It doesn't matter which way round you write these 2 terms. I've chosen to write it this way because when I then move on to factorise this pair and this pair, it's slightly easier. So looking at the first pair here, I can see a common factor there of 2x. So I can take a 2x out, which leaves me with x plus 1. And from the second pair, minus 5x minus 5, I can take out a factor of minus 5, which leaves me with x plus 1. It's all still equal to 0. And from there then I can say that I've got 2x minus 5 in one bracket, x plus 1 in the other, like we have above. Okay, so from there then, I've got 2x minus 5 upon x plus 1. Need an answer of 0. Again, it's a product here, which means one of them or both of them has to equal 0, meaning 2x minus 5 being equal to 0. Solving the basic equation there, adding 5 and dividing by 2 gives me x equals 5 over 2, or 2.5. And if the second bracket was equal to 0, x has to be minus 1. Okay, so a little bit trickier this time. We've got a quartic equation here to solve, which means we've got an x to the power of 4. So unlike your normal quadratic equations, when we factorise this one, we're going to have x squared terms in each of the brackets. So we can either factorise it to solve it just by inspection, or we can do it by splitting the middle term, and I'm going to do it by splitting up the middle term. So we're looking for a number that multiplies, or two numbers that multiply to give 48 and add to give minus 19. And our two numbers in this case are going to be minus 16 and minus 3. Okay, so splitting up the middle term, then we have got 4x to the power 4 minus 16x squared minus 3x squared plus 12. And factorising out then from the first pair, we can take out a 4x squared, which leaves me with just x squared minus 4. And from the second pair, we can take out a minus 3, which leaves me with x squared minus 4. So my two brackets then will be 4x squared minus 3 and x squared minus 4, which we have got up here. Okay, so back to an equation now equal to 0. Either the first bracket's equal to 0 or the second bracket's equal to 0. So if the first bracket's equal to 0, 4x squared minus 3 is equal to 0, so 4x squared equals 3. Then divide by the 4 to give us x squared equals 3/4. And to solve it for x, I need then to take the square root of both sides, remembering that when I take the square root, I get a positive and a negative answer. So I've got two answers, plus and minus the root of 3/4. From the second bracket, okay, so x squared minus 4 is equal to 0. I get x squared has to equal 4, which again gives me two answers, in this case plus and minus 2 for x. Okay, the next example then, a little bit more awkward because of the square root as the second term. Again, we can do it by inspection, or we can do it by splitting up the middle term. I'll do it for you by splitting the middle term, but you can see here that we have got an x as our first term, okay, and a root x as the second term. So, same principles apply. I'm looking for numbers that multiply to give minus 14 and add to give minus 5, which means minus 2 and positive 7 are the numbers I need. Okay, so if we split up the middle term, I'll have an x minus 2 root x, which was the second term, plus 7 root x minus the 14. And then taking out a factor here, well, a factor of x and root x is going to have to be root x, which multiplied by another root x gives me x. So root x minus 2 in the bracket. And then from the second pair, I've got a common factor of 7 upon root x minus 2, which takes me back up to here as my two brackets, okay? So root x plus 7 and the x minus 2. Okay, so equals 0. So either the first bracket or the second bracket or both are equal to 0. For the second bracket to equal 0, root x must equal 2. And to find x, we're going to square both sides, giving me x equals 4. For the second bracket to equal 0, root x has to equal minus 7. And again, squaring both sides gives me an answer for x. So x is either equal to 4 or x equals 49. Okay, the next example on this page is a problem type question. A little bit more complicated again. So we've got a piece of wire length 1 metre. It's cut into two parts and each part is bent to form a square. So a square having all sides the same length. The total area of the two squares formed is 325 centimetres squared. Find the perimeter of each square. Okay, so let's say the piece we cut off is x centimetres. Okay, so x centimetres is what we're going to cut off the metre. If I then bend that x centimetres to form a square, each side of the square is going to be x over 4 centimetres. Okay, so each side of this square is x over 4. So that means, going back to the first square, my original metre so 25 centimetres on each side, but I'm cutting off x minus 4 centimetres from each side. Okay, so each side of the other square is 25 minus x over 4 centimetres. And I'm told the total area of the two squares. Okay, so there's one side of the first square, so the area is 25 minus x over 4 all squared. The second square then, x over 4 all squared, gives me the area of the second square, and I know the total area is 325 centimetres squared. So multiplying out our first bracket, we get 625 minus 25 over 2x plus x squared over 16. And the second square bracket gives me x squared over 16. So just doing a little bit of tidying up, x squared over 16 plus x squared over 16 is 2x squared over 16, which simplifies down to x squared over 8, minus the 25 over 2x plus the 625x, and that's equal to our 325 still. Okay, so I multiplied through by 8 to get rid of the fractions, which now gives me the quadratic equation x squared minus 100x plus 5,000 is equal to 2,600. And then to be able to solve this, I have to have it equal to 0, so I need to take 2,600 away from both sides. So that now leaves me with 2,400 on the left-hand side, and again, we're going to factorise this. So, multiplying to give 2,400, adding to give minus 100, two numbers have to be minus 60 and minus 40. Okay, so going on to solve it, x has to be either 60 or x has to be 40. Okay, so the actual question on the previous page says, find the perimeter of each square. Okay, so the perimeter of each square, if x being 40, okay, so taking square 1, we've got 4 sides that are 25 minus x over 4 centimetres. So with x now being 60, that will give us 40 centimetres squared as the area of the first one. And x over 4 is the side for the second square. So 4 times that will give me 60 centimetres squared. So it doesn't matter whether you put the 60 into the first one or the 60 into the second one, or 40 into the first one, 40 into the second one, you'll still end up with the same two perimeters. Okay, moving on then from problem type questions into the quadratic formula. Okay, now, because C1 is non-calculator, we're going to have to leave any questions or answers involving the quadratic formula in surd form. Okay, surds you have met before, and all answers in surd form will need to be simplified. Okay, so in this question then, A, we've just got 1, B is 4, C is minus 1. Now it's worth noting at this point that you're not given the quadratic formula on your formula booklet. You do need to remember it. Okay, so make sure you remember that formula. So substituting the values of A, B and C into that formula then, we get minus 4 plus and minus the square root of 4 squared, minus 4 times 1 times minus 1, and that's all divided by 2 times 1. Okay, so simplifying what's in your square root, we've got 16 minus 4, which gives me 20. If I simplify my root 20 being 4 times 5, which gives me root 4 times root 5, root 4 then being 2, so that goes down to 2 root 5. And once I've simplified that, you can see then that you can divide by 2 from each of your terms. So that then gives you an answer of minus 2 plus or minus root 5. Okay, similar sort of a question then. Okay, so using the quadratic equation to solve this, sorry, the quadratic formula I should say, to solve this quadratic equation. A is 4, B is the -7, C is 1. Substituting those values into the quadratic formula then, we get this. Looking at your square root sign, so -7 all squared is positive 49. 4 4s are 16, so 49 minus 16 gives me 33. 33 is a surd that cannot be simplified, so there's nothing more we can do with this answer. We leave it as 7 plus or minus root 33 over 8.